Hi everyone. This is a second look at a style of question that asks us to find the mass given two delta H's and a balanced chemical reaction. This is a three-step process. We're first going to start by taking the delta H from the equation, dividing by the moles from the equation, the coefficient. Then we'll convert that into moles while taking the delta H from the sentence and dividing by our previous answer. And finally, we'll take our moles and multiply by the molar mass of the chemical we're focused on in the problem to find the mass. Let's connect this example. What mass of methane will be consumed if 360 kilojoules of energy are given off by the following reaction? We have methane undergoing combustion, reacting with oxygen to make carbon dioxide and water vapor, and there's the delta H. Let's notice we're going to find mass. What is the mass? And there's two delta H's, one in the equation and one in the sentence. Here's a delta H connected to the equation, and in the sentence up here is a second delta H. Let's go for it. Our first step is to take the delta H from the equation and divide by the moles, the coefficient. Here we have H equals the delta H from the equation is this one, negative 802.5 kilojoules. Negative 802.5 kilojoules. We're going to divide by the coefficient, the balancing number that also comes from the equation. This question is asking us to focus on methane. Here's the methane. It's balanced with a 1. This is not an amazing mathematical step. However, conceptually, it's a very big deal. We're converting delta H into H from the enthalpy change to the molar enthalpy, and the units in turn are going to change. Even though the number itself didn't change, this is a step that we cannot overlook. Step 2. Take the delta H from the sentence and divide by H, our previous answer. Moles. The delta H from the sentence. Here it is. Oh yeah, 360 kilojoules of energy are given off. Again, watch out for those language cues. This energy is given off. That's a little bit sneaky. It's telling me that the delta H is a negative value. Given off implies a release, a liberation of energy, an exothermic process. That's negative 360 kilojoules divided by my answer from before, negative 802.5 kilojoules mole. I take my time. I'm going to calculate it. 360 divided by 802.5. I get 0.448598, etc. moles. A number that I'm just going to keep on my calculator. I feel encouraged. I'm expecting a positive mass. There's no such thing as negative mass. So that my two negatives canceled out to give me a positive moles, that reassures me that I'm on the right track. Finally, the mass is the moles, our answer, multiplied by the molar mass. The moles is this answer that's still just sitting on my calculator screen. I don't want to round it off or do anything to it. I want to keep that same unrounded value. And now I'm going to multiply by the molar mass. This question asks me to focus on the methane. That's why I use the balancing number, the coefficient of the methane. Here it is. And now I need the molar mass, CH4. It's 16 0.05 grams per mole. 16.05 is the molar mass of CH4 of methane. This number is still sitting on my calculator screen. I multiply by 16.05. What comes out on my calculator is 7.2. So my raw answer, it's not quite finished off. Let me go back to the question. 360 has 3 significant digits. 802.5 has 4. So I actually need 3 significant digits. What came out of my calculator just has 2. I add that 0 myself to satisfy the significant digits, and this was the mass. Grams. There is a style of question that we're going to encounter that asks us for the mass given 2 delta H's and a balanced chemical reaction. It's a 3-step process. We're going to start with focusing on the values from the equation and then move on to what's in the sentence of the question itself. Watch those significant digits and units, and I hope that helps.